This is the first lab of Physics 2, and in it we'll be looking at charged tapes. We'll be gathering data about charged tapes and how charges may interact with one another. We'll be determining the necessary charge to make the tape float, and we use Newton's first law, the law of inertia, and the electric force formula to do this. The results were that the required charge was 8.977 E negative 9 coulombs, and the magnitude of the electrical and gravitational forces were identical at approximately 0.0018 newtons. For the computational model, the length of the tape were 0.185 meters, and as a result, the mass of the tape was 0.185 kilograms, and it began floating at 0.02 meters. For the necessary assumptions, each tape was treated as a point charge. Each tape was more or less identical to the other, and as a result, the magnitude of the gravitational electrical force on the bottom tape were the same as the forces applied to the floating tape. And I ignored the force of my hand because we were looking at the system as being the floating tape, and while the surroundings includes the force of gravity and the electrical force, the hand itself is not able to exert a force on it. So when we go to the code, I set the floating tape at the location where it begins floating so that my code was less complex, and I could set the distance variable as the observed minus the source to simplify things. And here I'm finding the gravitational and the electrical force. The tape Once the tape begins floating, the y component is zero, so they both cancel each other out, which is why gravitational force is negative and electrical force is the absolute value of it. To find the charge Q, I take the electrical force formula, I I expand upon its components to look at electrical field. And again, since the tapes are assumed to have identical charges, QB is the floating tape is equivalent to QA, the tape that I manipulate. And then when I plug everything back in and I rewrite 4 pi epsilon naught becomes 99, I plug that formula back into my code, and we run the code. This blue particle here is the floating tape, the orange is the manipulated tape. Yellow arrows are gravitational force, and red arrows are electrical force, sorry. So as you can see, those two forces are equivalent, they just act in opposite directions, and the necessary charge is listed there. So for the relevant lab questions, I found my U-tape to be positively charged. I used different tapes, I performed the experiment in different locations, and I used different pens. For whatever reason, the tape was still attracted to the negatively charged pen. I think it might have just been the glue itself and how it picks up or removes electrons. So as a result, the floating tape had a deficit of 5.61 E10 electrons, which I calculated on paper. There are approximately this many atoms on my tape, and I found that by using the length scale and then plugging it into uh, the area of a circle because I assumed that the tape was one atom thick, so I was able to use the two-dimensional atom. And for every electron, there were this many atoms. As for what if electrons had positive charge and protons had negative, there'd be no change in the calculations since the result was a magnitude, not a vector. But if it was a vector, then the electric field would have a different direction. And just because as long as electrons are more or less free to move and of opposite charge, the protons, electrical force, and fields are able to form and interact without issue. And it's important to handle the tapes as little as possible because the more it's handled, the more opportunity and time the tape has to achieve equilibrium. It just does this by giving up or stealing electrons from other surfaces because when they come into contact with them, they either equalize with the dipole already present or they create an induced dipole and trade electrons. And it does this regardless because the electrons always want, or the item wants to be at equilibrium. If I were to do this experiment again, I would try to do the pen and tape experiment in maybe a different location to see if maybe the humidity was too high